How's it going there? My name is Chandler Frakes, and this is Drawn to Brawl. Drawn to Brawl is a 2.5D fighting game. It is a 3D fighting game, and what I mean by 2.5D is that it is a 3D environment, as you can see in this gameplay happening in the background, and it is 2D in the sense that your character is a sprite, and all the animations are done in 2D in kind of a hand-drawn style, as you can see here. It's mainly black and white and not colored because these are essentially testing, animations, not really final drafts. What I'll go through now is how to open the game. To open the game, we are going to open the Godot engine launcher. You can install Godot from Godot's website. We ran with the Godot engine with .NET support for C Sharp. However, we ended up sticking with the built-in language that Godot has, and it's called GDScript. But once we have installed the launcher, we will do import project. And since I already have the project imported, it's right there, but you would go to where you cloned the repository from GitHub, and in the source directory there is a project.godot with the little icon here. So you'd import it there, and then you would click import and edit, but as you can see I already have it. So we will open that. Once you are brought into the editing UI, we can go into the top right corner. It should be all set to go once you clone. This is off of the dev branch, not main. If we click that little play button, there's a slight bug on dev where the UI elements in the background do not scale properly, but that is being fixed currently. And we will go to fight a CPU unit. And so we will select our ranger character. We can also do it by dragging this nice little token right here and selecting the ranger. And now we are in the game, and how this game controls is with just WASD. You can move in all three directions and spacebar to jump. The attacks are U, I, O, and P on the keyboard, and we also want to support gamepad gameplay, so we wanted to really file it down to only a few buttons. And so U is your normal close, and then you have a normal far, which is I, and then O is a special close, and P is a special far. So there's a normal and far variant to being a close move and a far move. You can use the close and far moves whenever you want. It's just that the close moves are obviously going to be more advantageous when you're closer. The far moves might be like a projectile or something, and it might have a lot of startup frames and a lot of frames where you're vulnerable, so it would make more sense to use it if you're farther away. Mind the slight physics bugs that we have right now, but and then you have your close moves that are more quick. And then there's also a ground and air variant of all of these moves. So, and I guess how you win in this mode, obviously you're not playing against other people, but we do want to have local multiplayer ready to go. But there are lives. I think all the bots here have 3 lives, and so once you eliminate all of them about 3 times, that means you've won the game. Similar to Smash Bros. And the stock system that they have.
showing you the different tools that we use to build this project. So first off, for the project itself, for all the code and the game engine, whatever, we decided to use Godot. And one of the reasons we used Godot is because originally we were going to be using Unity, but then Unity started to do some sketchy things with their payments and whatnot, and potentially they wanted to require people who released games for free to also pay them if like those games got a bunch of downloads. So we ended up learning about Godot and we decided to change to it. And honestly, we sort of enjoy the change. Godot, in our opinion, like feels way better than Unity, and it's pretty straightforward. There are some things that aren't as great about it, like for instance, when you're pushing your code, every so often it will tell you that you changed a file that you may have never edited, because sometimes some of the files, background variables like load order and whatnot, gets shifted around just from the act of you opening them. But so how you install Godot is you just go to the godotengine.org and look under their downloads, and you just download it, and then just run through their exe and extract. For our repository, we are using GitHub, and so this is where we have all of our code. It's pretty straightforward. You can create branches and pull requests here and see all the code and clone all that. And what most of us use for pulling the code is a tool called Git Bash. So Git Bash, you can just right click and open it, and then you just see this little page and you can type, say, git status to see how your branch is doing, git push, git pull, git add, git commit, all these normal git commands to push and pull the repository up and update your code. For our 2D sprites that we used for all of our characters, we used a tool called Procreate, which is a software sort of similar to Photoshop in a way. It's a drawing software that you can use with tablets and whatnot. And Chandler is the one who managed to put together all of our different pictures. And we really enjoyed them, so we really liked them. We kept them in. We also used for any of our non 2D images. So for any of our non-menus and non-sprites, we used Blender, specifically version 3.6. It may not matter what version of Blender you use, but sometimes maybe they won't be compatible with one another, so you might need to use a different version of Blender to edit pre-existing maps or pre-existing objects if you wanted to edit those. And so Blender is just a very robust 3D modeling software, and it's very complex, but it can do basically everything. So it has its ups and downs. For instance, you can do just about anything you'd want in Blender. You could even make animations in Blender if you wanted to. You could do anything. But if you're just doing simpler things, it is kind of hard to wrap your head around because it is very complex. You need to go through a bunch of tutorials. Finally, in order to get objects from Blender over to Godot, all you need to do is when you're in the Blender scene, you just go to your select tool and you select whatever you want to have. So I could click on that, or I could just start clicking on these on the side or whatever. And when you have whatever object or objects, if you wanted multiple that you wanted to export, you just go to File, then Export, then you click on this GLTF 2.0. That will in turn make it a GLTF file. And when you make that file, you export it over to a folder that your game can see. And then it's pretty straightforward from there. All you need to do is when you are trying to finish exporting the map, finish bringing it in, you just go to wherever that GLB is, right click it, and you can do new inherited scene. And then when you do that, you'll get something like this. And then if you want to make your meshes, you can just click on the different meshes and click this mesh button up here and select one of the options and it'll give you some meshes. Sometimes I will note this mesh button up here doesn't exactly work. In those cases, you might need to personally create a mesh, which has advantages. Of course, the disadvantage is it takes a lot of time to make a good mesh, but the advantages are you can see, for instance, this mesh has a lot of extra lines that realistically we don't need. It could probably just be one cube here and then a rectangle there and there, instead of all these extra lines, which would make processing better.
Hello, this is Kyle, and welcome to this portion of the project turnover video. In this portion, I plan to explain how our installations of our project, so what we have installed, and to walk through a little bit of the code as well. So, uh, as mentioned by Alex previously, you should already have Godot installed. The version at which our project is made is 4.2. You should have already mentioned that, and we have some various add-ons into our project. One of the big ones being uh, rollback netcode, which is from an add-on from David Snowpeck or snowpeckgames.com. You could go to his website, davidsnowpeckgames.com, or snowpeckgames.com up here, and if you click tutorial/courses, you'll see a entire section for rollback netcode in Godot. We already have this added into our project, and we've been working with it for the second semester, and we've been slowly trying to convert our project into rollback netcode. And if you don't know what rollback netcode is, it is essentially a way for multiplayer synchronization that is commonly used in online fighting games, and it tracks the entire state of the game by hashing it. It also does some inputs detection. So it detects the player's inputs and sends that over the network. And then all of the player inputs are sent to other clients. And then that input is used to run the game simulation individual on each person's computer, which is basically kind of the essence of rollback netcode. But one of the main important features of it is that rollback netcode requires a deterministic environment. And what I mean by a deterministic environment is that the stuff that you put into a system uh, based on the initial conditions always have the same output set of conditions. And you'll see we're going to have a little troubles with that. But that's basically what the sense of rollback netcode is. And he has a whole tutorial series, David Snowpeck, on this, and I strongly recommend that you watch all these videos if you're going to be interested in understanding what's going on under the hood. I won't be able to explain everything as good as he does in the tutorials, but I will touch up on some key things that we're using that may be of interest as we walk through the code. So, other than that, we also have a custom Godot physics engine called Godot Jolt, and you can find it here at the github.com, Godot Jolt / Godot Jolt. It's already installed into our project as well. This physics engine is different from the default Godot physics engine. Particularly, we're using the 3D version. Uh, Although it isn't a deterministic 3D engine, which is a requirement for rollback netcode, and Godot's default 3D physics engine isn't deterministic as well, this one should be closer to determinism. It can't guarantee it, but we've been using it just in case as well in our project. So it's important to note that if any physics behaviors come our way, or if this updates, it will have to be updated to the project. But as of this video, 2024, we're using the latest version of this physics engine, custom physics engine. We also have some custom physics drawn within as well, within the code, and I'll go up and touch about that when we get to it. Alex also mentioned that our code uses GD script, and these are just some images. It's basically a scripting language, interpretive, because you could also write code in C++ in Godot, but we chose to do GD script because we all have great experiences with C++ in school. But enough of that. It is a pretty simple programming language, very similar to Python or Lua if you've ever worked in those. And other than that, the way Godot works just if I go ahead and open, if you look at the left here, this is kind of the scene of this current, or the current setup for this scene. How Godot works is everything is set up as scenes. So this base character is considered a scene, and all these objects inside it are all considered sub-scenes of that. Or you can also call them nodes as well. The term is somewhat interchangeable, but in Godot, scenes are built up of smaller scenes, and this kind of image describes it. And this is kind of known as inherited scenes almost. But you basically build small stuff at a time, and then you use that to build bigger scenes, which you can then use for later. And the Godot rollback netcode add-on that I mentioned earlier adds some new scenes as well, specifically for rollback netcode. So, other than that, we also have the Godot PlayFab add-on. Now, we didn't get around to using it, but basically this add-on was going to be used for online lobby making and matchmaking, but we just simply ran out of time for the scope of our project, and we're hoping that another team will be able to pick that up. It is installed, but it's just not being used at the moment. Alright, now on to the actual code, but a little not actually. Before we do that, here is our GitHub repository. It's just simply called Hyyvmind, and as of this recording, we still have a couple branches on, and master is kind of the main branch. We also have the dev branch, which has all the code before we started integrating rollback netcode. So basically imagine semester 1, and then our like second quote unquote dev branch, you may say, is called multiplayer merge. And this branch has all the code that has rollback netcode, and this is the branch I'll be talking on. Both branches are similar in terms of code structure and such, but this one is more pertinent for the continuation of the project, per se. We also have various other branches for features that we just never closed out, or for debugging issues, but mainly these are the ones you want to focus on. So, to look at the code, open up Godot, open up the project, make sure you already have everything installed, and make sure you're using Godot 4.2, and you'll have something like this, depending on your view. I'm just going to close out. This is like the default Godot view right here. To look at our code actually itself, you want to open this source folder. And Godot creates two types of like main files. There's .gd files for code scripts. So if I open this scripts folder, you can see that we've split it up into classes, game control, various types of scripts. You can always search for certain files by typing up in here. If I search up like core, I'll get the core match controller shown up. But anything related to UI, all the scripts are in here. If you double click this, you can open them and it'll show up in this scripts file. I'm just gonna close all these real quick while we talk. And they're pretty simple for the most part. Most scripts, how they work is they get attached to nodes in scenes. And to describe scenes, these are TSN files, and we have a folder for this called scenes. And you can see them for UI. This one's for like our levels. So if I can open the saloon map, click 3D to go into the 3D view, and we can see this is the scene for the 3D map for where the players, or the saloon map. If you're not seeing this, make sure you select 3D at the top, because this kind of flips between your code and versus not your code. And if I look in the scene kind of hierarchy up here, you may notice these little script files that are attached to certain nodes. So this canvas layer has a script here. This spectator actions has a script here. The main scene has a little script here. You can click these to also open that. But this will kind of take you to the code that is currently attached to that specific scene. And so one of the main reasons we have it separated is because you will end up not copy pasting, but attaching the same script to multiple different nodes. So for example, all the maps, they use the same core match controller script here. The castle map here uses it. The saloon map here uses it, and that's just for code reusability's sake. If you make one change on one map, you won't have to make it on the other. Other than that, though, there are some important code files that you would need to know if you are going to be continuing this project. And I guess we could talk about this one first because I already have it open. The core match controller. This specific script, its purpose is to, once it receives a request to spawn in players, it will load them in, give them their unique IDs, and set up any networking stuff that they have to do. It will start the match by setting up everyone's lives. So this script kind of manages the live counter for the players, and then once it determines that someone has won by determining if like the last one alive based on the lives mode, it will transition the game to the victory screen. And the victory screen is more UI code, and you can view that code within the UI folder. Another important script that is used is the rollback character script. And I'm going to pull up the rollback base character. This is kind of the base scene that all of our other characters inherit off of. And they have a base script here called a rollback character controller. And this uses a lot of the rollback features that I specified from the rollback netcode add-on. Also, just to clarify, at the top of the scripts, you set a class name, and because every node extends off another node, you'll see the word extends afterwards. So we're extending off the Godot's base implementation of a character body 3D, and it's in a class called rollback character controller. Just wanted to let you know. And as well, there's another character, base character, and this is not the rollback compatible character. So that's kind of the difference between character controller versus rollback character controller. One is rollback compatible in that sense, but this is kind of like the meat and potatoes of how characters are handled. So everything when it comes to character animations, character cooldowns, their movements, and any custom physics. So we do have a custom physics in here. This network process function is part of the rollback netcode add-on. It's basically runs every frame or so. So if you're thinking of games that run at 60 frames per second, this runs technically at 30 frames per second because we did some configurations to that. But yeah, we have some custom physics up in this as well. Anything that's related to inputs and physics for characters in specific will be in here as well. There's some save state and load state functions. I mentioned earlier that how rollback netcode works is that it saves a state of the game basically every frame, so it can roll back or basically turn back time internally to determine hit detection and synchronization issues. So you'll see these methods a lot in a lot of rollback pieces of code. You'll see the network process function a lot in rollback stuff. And there will also be some various rollback stuff as well, like get local input, which gathers the player input and then sends it over the network through a message serializer class that we have. If I search a serializer here, there's a lot of right here. This is not too important, but it will be important if you want to add extra inputs. This class is basically a custom class I wrote to parse the player input to compress it into or serialize it into smaller byte packages, and then deserialize it once it's received. And this is a very important code file as well, because the bigger your network messages is, the laggier your game can feel to the players and the more kind of bandwidth you're wasting. So it is important to compress it as much as possible. But this, in conjunction with the rollback character controller, handles the main player input for the game in general. And for this, we also build off some custom nodes that are integrated from the rollback netcode add-on. So if you see something like a network timer, for example, that is basically a rollback safe version of a regular timer. And timers just count on seconds. So like this timer right now is set for 1 whole second, 30 ticks per se. We also have a network animation player, which we use to run our character animations in. And it isn't exactly code specific per se, but the code does use animations. And if you ever want to edit animations and such, this is where you would do it, in a network animation player. One of the last files I just want to talk about real quick is this thing, this scene. It's called the main scene, and it looks like nothing, but on the left here, you can see it's called main scene. This is kind of the overall scene for the entire game. So if I actually go ahead and run a play right here, the music is... I'm going to have to fight over the music for your audio, but if I go ahead and click remote here, you can see that main scene is right here. Sync Manager is just a Godot or a rollback netcode thing. But you can see the main scene that has a node for players, a node for the map, node for the UI, some spawners for the characters, and map for multiplayer purposes, and music as well, and a little leaderboard that you could see at the top. And while I'm in this remote section, you can actually see it actively update. So if I go into the UI now, it changed to the play scene. If I go it again, it's now the multiplayer connector. If I go again, it's now the player select screen. And you can use this to help debug stuff. I just loaded into the saloon map, and now it's loaded up here. And this is basically what remote is. It's the active updating. You do have to switch out of the game to get the updates, which is kind of annoying, but it's all right. But other than that, the main scene, it has its own script as well called mainscene.gd. And basically, what this script does, it does various functions related to selecting maps, switching players' UIs, as you could see within it, and spawning in players as well, and also general networking stuff. So this is where we start like a sync manager, which is used for player networking in rollback netcode, and spawning in players into a map is here, or map voting, or determining what current map is in the game, or logging even. This is something Chandler will touch up more on the debugging section, on how to deal with like fixing issues with rollback netcode, because they aren't very obvious, or disconnecting multiplayer sessions, picking a map, voting, changing the UI here is another example. You'll see this ob node is used a lot across various other scripts. So if you are ever like wondering, hey, what does this change UI function does? Just jump in the main scene and you'll be able to find it. And that kind of just goes for a lot of the scripts here. So in the play menu here, it says main scene. It uses it. It's referring to this section of code. Other than that, that's kind of the overall gist of the project structure, how we divided it up, and what systems are currently in place. I highly, highly recommend you watch David Snowpeck's YouTube tutorial series on rollback netcode, and also pick up some GD script and general Godot 4 and beyond programming skills. Godot 4 in specific, because Godot 3 has some changes to their API. If you like need help with the API, you can search it up, Godot API, and you'll get all the documentation listed online, which is actually very useful and convenient as well. And you can search the docs as well. I will also warn that the tutorial series that David Snowpeck has currently on his channel, as of this recording, is still in Godot like 3.5. So you will have to do a little bit of code converting. But I've already watched the videos and taken notes on it, and Abby will kind of touch on more. That's in our team drive about that. But other than that, thanks for watching my part. And I'm going to pass it over to Sean now, because he has more about the neural net code modeling, or player AI stuff that I cannot explain because my brain is a little bit too small for that. take it away, Sean.
Alright, so this is my portion of the rollover video, whatever it's called, discussing the neural net concept that we were interested in implementing as a team. So, on screen now is a 2D example that I had worked on during Sprint 3, during spring semester, involving running a model neural net process. I'll get that started while I continue talking. This was to show off the algorithms and the ideas behind the code being used to be able to procedurally generate desired behavior given a set of circumstances and a set of action. The final project doesn't particularly have a strong version of this. The 3D version involving a moving target was, I suppose you could consider it, we underestimated the amount of work required to succeed in this front, but some of the theory will still be present in the version of the behavior that is present in the version that whoever receives this project, I mean, I assume this is just going to the same people, but the people who will be working on this project will inherit that code and that rudimentary implementation of the formulas and concepts that we've built on here. What's going on screen is you have a player character represented by the little gradient cube in the bottom, and his goal is to make it to, well, the goal, which is the Godot icon that is in the upper right of the screen. You can see here we have some of these displays. There's this white and blue one, very prominent, which represents what the player, like just the player's environment, simplified down into blue and white pixels, with the red one being the character itself. The displays that are like black and red and green, those are the quote-unquote layers of his model. These will go off and try to execute particular actions if the environment around him is in a particular state. So in a sense, if a blue cell maps onto a green cell, then we will attempt to take the action. What's actually, I think, more intricately going on here in terms of the green and red is that the green cells are like a positive weight and the red cells are a negative weight. So if we see a block and it's within the space of a green cell, then we will like increase it a given evaluation value by 1. I don't know, some arbitrary value. And then if it's a red, we decrease it by that amount. Brighter green cells and brighter red cells have a stronger weight, so maybe like 2 or 3 towards that weight. And essentially, if the entire evaluation across the entire grid is a positive number, I think it might be a positive number, yeah, then we will execute that action. And I don't have them labeled on screen, but the top one is a jump. The bottom, or the middle one is for moving left, and the bottom one is for moving right. So what this essentially does is, as long as you have the right weights in the right area, you can essentially guarantee behavior based on a specific set of starting circumstances, while still having that behavior be complex and respond to the moving, changing environment around the cube. Like, imagine if you had a moving platform or you had gates or something, you could have the player model theoretically respond to that information in real time. Again, like I mentioned, we wanted to implement this for the game. A version of it, a very, very simplified version of this, it will be present to you, but the modeling that I had done for this particular demo was not extremely useful in dealing with a goal that was moving, in dealing with dealing with geometry that was uneven and not cellular like this. You know, it's just on a grid here, but with our models, we have slanted slopes and we have intricate designs, and we have vast expanses of terrain to deal with, and we have collision to deal with as well. So this model did not translate exactly over, That's why we have spikes like this to figure out exactly what we might do, and then, we end up always changing everything when it comes to implementation. So that's this bit. You can see here that the fitness of this isn't going up, and I'll explain more what's going on here. I guess I'll let this run to the side, or I guess maybe we'll just close it, but we'll talk a bit about the code that's going on here. So in this example, which will be available to you, I believe I made this public a week ago, so you can take a look at this code and try and understand what's going on here. Essentially, first we're creating some of these displays that you see on screen, so you can have a visual understanding of what the model is thinking. Godot is terrible about just letting you create multi-dimensional arrays, so this is what's happening there. More display generation, and then this is the actual chunk of the code that matters. So the way we try and short circuit the development of a successful model is we essentially do series of generations, and in every generation we do a series of attempts. So within a specific generation, we'll run, 30 or so attempts. I think we have a variable up here. Yeah, we run 32. Sorry, that's generation. In this scenario, we run 100 attempts. And in these attempts, we choose to just take whatever our base model is at the moment and run some variation on that. So picking a couple of random cells, altering their values along the array, and then giving that model to the character, setting the goal. And then you create a character with this model with this model set to it. This code essentially just says, hey, let the character run until it has to close. This is just awaiting a signal from the character that it's unsuccessful or successful or done or whatever. With that information, depending on some of its circumstances, including how far it is from the goal and if it actually succeeded in making it to the goal, we give it a fitness evaluation, which is how well do we feel it succeeded, and then we take that value and we keep track of it. At the end of the generation, we take a look at the top fitness, and we take that model, and that will become the base. You'll see here that the model becomes a duplicate of the top fitness model. And then what this does is the next model will have the success of the previous generation of attempts, whatever excesses it accrued, and then base its new behavior off of that. So that eventually, hopefully through enough generations, we will randomly land on the model that fits our needs the best. Obviously, when I say random, it's a very guided type of random. I think I generally use the word procedurally because it's not, deterministic that we will arrive at a successful model, but it is very likely, and we are doing, in the theory suggests that we have to do our best to bound the possibilities of a successful model so we can arrive at it faster. So that's the theory behind this. There's a bunch. This is all the display code that we have up here. Again, the main reason we were not able to implement this exactly as is because because of time constraints. We had essentially a sprint and a half. I'd say maybe 2 sprints worth of time following the completion of this, and this is again for the sake of putting it towards the CPU behavior, and we figured, or at least I figured as the sole developer on that, that we would much rather make sure we have completed behavior than implement this system, which would be more robust for our needs, would be more intricate for our needs, but would ultimately take more time that we don't have. So it's unfortunate. that's how it is. I guess we'll come back to how this is looking. Just to say, it's not doing very much, but to be fair, we have a lot of attempts and a lot of generations to run through. Things like the fitness function and the generation function and the amount of generations and the amount of attempts you do are ultimately up to the user. I think they're flexible in terms of how you want to set them and how you want to see your behavior grow. The numbers I chose were of a trial and error process determining exactly what I felt was the best, although I think I changed, for some of the successful attempts I did, I successfully changed. More yawning. I changed some of the parameters. I think I did like 16 generations and 25 attempts per generation, so, use at your own discretion. But yeah, that's it for this particular section of our code and our turnover video.
Alright, and now we're going to talk about debugging the game and how we troubleshoot as well as test our code. Great resource that we tend to refer back to a lot is the Godot documentation, as we use the Godot 4.2 API. The Godot documentation website is docs.godotengine.org. And so looking at debugging our actual project, there are a few ways that we go about this when we are testing our code. One of the ways that is possible that we don't usually do, but it is certainly possible, is using the built-in breakpoint feature. This was handy for specifically figuring out an issue with rollback, but what I will show you is how this works. What I have right here is our move update function, so whenever we attack, this is going to get called and it is essentially going to execute the move. And so I put a breakpoint on line 68 here. In fact, I will actually just move this so that we get out of that and we actually are in that execution phase of the move. But as far as the actual debug settings go, what I like to check, you certainly don't have to, as we already have built-in debugging for hitboxes, but I do like to enable the visible collision shapes. As well as for testing rollback code, we run 2 instances, as this is our networking, and one of the instances will act as the server and the other as the client. But on one of these, I will go to the multiplayer screen and then we will create a lobby. And then for the other one, we will join the other person. And then once we are in the game, we can run around. And then I will go and I will jump in the air. And then we will hit this breakpoint and then it will stop the game simulation. In fact, it is loading, it is waiting for us to continue. And with this menu, it is actually pretty useful at times. You can see what the current state of the game is and in what class you are in, depending. It will show you the state of the variables that you're using and all that relevant information to be able to figure out what the issue of something might be. If you're like, let's say this hit scan is required for a move and it's null, it'll show clearly right here if you get to this point and you need it to not be null. Another way that we like to debug our game, and if you're a software engineer, then you certainly know about print statements. So let me just pick a variable to log out. So I'll just do move name, actually move input. So we'll log what input we are pressing when this move is executed. And so I will just simply log move input. I put move input space, so it'll print out into the console output right here. This is an input, it's an example of output, and then comma to append the move input to this output string. This is handy for when you need to know at a certain point in your code what the state of some variable is, which can expose underlying issues if something's not being set correctly. And so move around a little bit, and then I'll jump in the air, do my move, and then we see right here that stop the game, and then the move input was printed out, that my air normal close was being executed. For rollback specific issues, we have implemented a log inspector, and this is actually quite useful for testing rollback specific issues, as it can show you the state of the server and the client at a specific point. Okay, we'll just do, I don't know why I didn't do the first one. So you can advance each tick that is essentially a simulation of the game. So each simulation, there might be something that is different, which we always view in this bottom right window. It will show you that, see, the hitbox object string was different on the local and the remote client. And so there was something going on at that time. This was from probably a few weeks ago at this point, a log from that. And so I was having issues with the object not being able to have a deep copy of itself. And it shows right here that the objects themselves are different on each, on the server and the client, on the two instances. What is also pretty useful for coding with Godot is VS Code. I know a lot of software developers like VS Code for its versatility and simplicity. It's very lightweight in terms of editors, but if you have certain Godot add-ons, it will detect that it is GDScript, and it'll implement linting for GDScript. And it's also very nice to integrate with GitHub or your Git accounts to be able to commit changes and right from your IDE. In terms of specific settings that we use, when we are debugging rollback, there is a plugin that we use. It is from the Snowpack Games rollback add-on. On the project settings window, you scroll down in the general tab, there's a network section, and we have the rollback settings for this add-on. And what we do usually is we force for 4 rollback ticks, and then in random rollback ticks we will do 10. So this essentially randomly will roll back 10 simulations, and then the hard set one is at least 4. We're at least rolling back 4 times, and so this exposes a lot of bugs in our game that we might be coding things in a non-deterministic way.
This is our repository for all of our documentation and research base for our project. Here in unfoldered, our unfoldered documents are just kind of uncategorized random things, such as our different milestones, which are proposals for what we wanted to complete at certain points, our original roadmap, and different notes and proposed ideas for the game. We have our project setup steps document, which kind of explains how to download and set up the project. We have our final presentation for semester 1, our senior design catalog submission. We have our most updated roadmap of everything we want to complete, and we have just our poster and just some other documents that kind of have been abandoned but we work off of. Then we have our first folder, which is the documentation folder. And here we have 2 sets of notes. We have our Godot rollback notes. This has GitLab links throughout, linked to show examples of different parts of the rollback. And then we also have different YouTube links throughout it to kind of go through tutorials of how to implement these parts of the GitLab links. We also have neural net notes. Neural net is what we are using to implement an AI gameplay mode. Throughout here you can see different findings that we have and examples for how to do certain things. Our next folder is our headshots folder. This just has all of our headshots for our senior design poster. Then we have our maps and assets inspo. In this folder we just collect each document is a different set of assets or scene, and we just collect different photos as a group that we want to discuss and talk about to try to figure out what we'd like the most for our game and what we think matches our game the best. Then if we go back, we have our media folder. In here we store our art, music, and sound effects. Under art, we have even more. So we have the dummies, and our core, and you can see this is kind of what we wanted our dummy to look like for like training modes when you're trying to learn different things. Then we have our ranger. So these are going to be all the basic ranger frames. Oh my goodness. And then we have the moves, so each individual move has its own frame set. And then we have that for the noble as well in here, and it's all in here. So these are the different moves and frames for the noble character, both mocked and finished. And then we have menu mocks, which are broken down by the type of menu and the different pieces. Because of how the game is implemented, we need to have each individual piece so that it can be made into a button, and they're all going to be broken down the same way. Then we have just our main idea sketches throughout here for the saloon, the different characters, our logos, the first draft of our main menu scene, and all of our draft scenes are in just this main part. Then we have our music folder. This is currently empty because our music isn't stored in here. It's actually posted on YouTube and on, I believe it's posted somewhere else. I can't quite remember. It might be SoundCloud. I can't remember. Then we have our sound effects folder, which is broken down by the different types of sound effects we want. So for the ranger, it's broken down into all the different moves have their own sound. And it's going to be the same for each of them. I believe we only have a few finished, but there's more sound effects coming soon. And if I come back, we have all of our meeting notes. So whenever we have an important meeting that someone misses, we have notes taken for those meetings. Then we have all of our reviews and retros throughout the whole year. So we have the fall semester and then our current semester. And then we have our weekly reports, which are just our weekly assignments for senior design in here. So that's all we have for our documentation. Thank you for watching our video. If you have any further questions, we have a Discord channel that you can add. That's this top one. We are all a part of it and all are willing to answer any questions you have. The Snowpet Games Discord is also a great resource for the rollback. Any type of rollback questions or anything, that's what we've been basing our rollback off of, and so it's a great place to ask questions to more than just the team. If the team doesn't know, we'll probably refer you to them. And also, you can follow us on Twitter and ask us questions on Twitter if you have any. Thank you.